So without further ado, I will introduce today's talk, which is Helen Scott's amazing talk, which is writing code is easy, being a great developer is hard. Right, over to you.
Amazing, thank you. I'm going to hand back admitting people back to you now. So just before I start, there is added danger to the talk today. There is a plumber upstairs above my head ripping out a bathroom. So if the plumber or the bathroom or water suddenly comes through the ceiling, you know, enjoy the show. He has finished taking all the tiles off the walls, so I'm hoping the sound is going to be better. But just a heads up, it's not a typical day. The good news is I managed to get this glass of water before he turned the whole water off some 2 hours ago. So, all right. So welcome to my talk today. Writing code is easy. Being a great developer is hard. My name's Helen Scott, and I'm currently a Java developer advocate at JetBrains. And I wrote this talk because I graduated, so I'm giving away my age here, about 20 years ago with a stereotypical computer science degree. And then I went into the stereotypical job of Java development. We even did Java at university back in the late 90s. University was very forward thinking in that respect. And I walked into my first job as a Java developer and I failed. I failed really badly. I failed so badly, I quit my job, I left the country, and when I returned to the country, I carved out a career in technical writing because I was absolutely convinced that I couldn't be a developer. And now, as part of my more recent role as a developer advocate, I've come full circle and I'm looking back at that experience, and I'm looking back at all the skills I've gained working in software teams for the last 20 years. And I'm trying to understand why everything's so much easier now. Like, what happened? Why did I fail so badly back then? Did I just drink too much? Possibly. Did I not know how to apply myself? Potentially. But my hypothesis is that learning code is the easy part, and it's all the other stuff that we have to learn on the job that's the hard part. So where do we learn? Well, if my slides are going to move along, there we go. Primarily, we learn in three main settings. The first one's university. It's very academic. It's the route that I came through. It's very theoretical. Sometimes it's a bit boring. Spread over 3 to 4 years. Maybe you did a placement year. Second one is bootcamp. This arguably is a little bit theoretical and a little bit practical. Normally spread over 1 to 3 months. I know some boot camps are longer, but again, that's another perfectly valid approach that we have. The final approach is self-taught. Now, if any of you in the audience today are self-taught, my hat does go off to you. Huge kudos, well done. I think it's awesome. It's a very practical approach to take, and of course, it's spread over however long you have. When I gave this talk as a dry run to a colleague, she actually let me know about apprenticeships as well, and they're quite new and quite up and coming. So I would love to hear from anyone at the end of this talk who is on the apprenticeship route to understand what that looks like. But all of these have advantages and disadvantages, as I said, came through the first route. But what do we learn? Well, at university, this is what I learned. This is the modern syllabus for the 2021 intake of students for the same university I went to, University of Sussex. If any of you know it or went there, awesome university. It's not changed in 20-something years. Don't think I'm going to give something away. The topics that are still taught and still covered are largely the same. Very heavy emphasis on programming, not a surprise, mathematics, data structures and algorithms. Who doesn't love a bit of data structures and algorithms? I can remember doing the module on human-computer interaction, so I know that one hasn't changed. But then I thought, well, what if that's just my university? What if it has actually changed? So I went and I looked at other universities, and they are much of a muchness. The picture, in fact, the picture across the world was very, very similar. There's a few modules that sneak in, like computer music, sounds kind of fun. Data science and robotics also sounds kind of fun. But arguably, they all teach you how to write code. All right, well, what about bootcamp? It's a smaller list. We'd expect that because it's not run over the same length of time. There were some interesting things that started coming out when I looked at bootcamp syllabuses, though, in that it started to become a bit more practical. There were things like managing Git and GitHub. I was like, well, okay, pretty sure we don't even learn that at university even nowadays. Modeling and building relational databases, using the CLI, working with REST. These are all things that are far more practical and far more applicable to our day-to-day lives. Self-taught. Similar, but again, very much more practical. I also suspect with self-taught, and if anybody out there can validate this, then that would be helpful. But I suspect with self-taught, you learn a lot of the practical applications sooner than the rest of us. I expect you're better at time management. I expect you're better at life balance. And there is also a very interesting module called Thinking Like a Developer, which I was quite intrigued about on one of the, I think that was on one of the Udemy courses that I saw about, you know, teach yourself Java in 5 days or something, equally not helpful. So what do we learn? Well, we learn to write code, right? That's what we go to university for. It's what we go to college and bootcamp for. But what comes after writing code? A real job. And it's really worth remembering at this point that once we leave any structured education that we've been in, we are all self-taught at this point. We're all on the same level playing field. But this talk is called Writing Code is Easy and Being a Great Developer is Hard. So let's talk about the hard. So these are self-taught skills that are the ones that I've learned in the last 20 years of working in tech and more recently as part of numerous development teams, having seen the inner workings of many product life cycles and the people that create them, including myself. So for each skill, I'm going to take you through what it is, why it matters, and where you can find out more. Some of the learning resources are blogs, some are video. We all learn differently after all. There is going to be a QR code at the end, and I'll paste the link as well to the chat at the end for all the resources, so you don't need to scribble them down as I go along. They're relevant to you irrespective of your experience. I am going to take you on a journey. I'm going to start with the supposed easy stuff and move through the skills in the order that you're likely to get to them in your career. If you've been developing for a while, then you're probably going to recognize quite a few of them, maybe even all of them. You may not have recognized them as skills in their own right, but you're going to recognize them. And in that instance, I really hope that you take a moment to recognize them as the independent self-taught skills that they are, and in turn, help others who are fresh into this career. Put some training in place to help them if that's within your remit. And if you're relatively junior and you're still the one that's slaving away learning code in the evening whilst doing a job that you're not particularly enjoying, then consider this a whirlwind tour of just some of the skills that you're going to acquire on your path to greatness. Okay, now my timer on Keynote has broken, so I'm going to use my phone to check the time. All right, first skill, Googling, or professional plagiarism, as I call it. So here's the thing. We go to university and we're taught that all our ideas must be unique and elegant and our own. And every wheel that we come across, we must reinvent in our own special way. In fact, they even throw you off the course for plagiarism. And then you go into the real world and the model is completely flipped. You need Google. In fact, people look at you strangely if you don't Google stuff. And you certainly don't reinvent wheels. You don't write functionality if there's a library to do it for you. So being good at Googling is a skill. And if you're not convinced it's a skill, I encourage you to watch one of your less technical friends or family try to Google the opening hours of a shop and just see how quickly and how infuriated you get. It's about knowing how to optimize your search and knowing how to pick through the results to understand what's relevant to you. And it also comes down to how well you can relate to other people who are describing the problem and the technologies. It's how well you can really think like everybody else. So there is an amazing blog that somebody called Joshua Hardwick keeps up to date. And he goes through and regularly goes through and trims this list as to what's been deprecated, what's new, what's added. And you may look at something like that saying, oh, I can find 2 words within 4 words of each other and think, oh, that's not very useful. But when you're down a rabbit hole trying to solve a bug and trying to find specific pages about a specific topic, this kind of skill is really useful. So you leave university, you realize you have to Google to survive, and then you have to read code. The problem is we're taught to write code. We're not taught to read it. Furthermore, we're taught to write brand new code. We're taught to write code from the bottom up and then tie a little bow around it and put it on a pedestal. We're never really taught how to read existing code. Instead, we just go out into the world and we're armed with sticky tape and prayers. And if we're going to apply that sticky tape and be able to read the code, irrespective of who wrote it, we have to have that as a skill set. Now, yes, your IDE can help here, but that's not really where I want to focus. It's about you, and it's about looking for design patterns. Even the indentation can tell you a lot from, thinking about the scope. Something else that's important to recognize is that code does not tell a story. Okay, technically there is a start in Java, but there's not a start, middle, and end, right? You have to, certainly with a big code base, you have to pick a point and then expand out from there, pick another point and expand out from there. It's not a simple text-based dungeon crawl that we used to get in the 80s. Resource-wise, got quite a few for you here. First one from Trisha G. She made a very interesting observation in that it's funny that computer languages are the only languages where one learns to write before learning to read. And it's not uncommon for people to never really learn to read the code. Doesn't that seem a little unbalanced, given we read code more frequently than we write it? And the first time I read this, I thought, she's got a point, because I'm learning Spanish, but I can read Spanish a lot better than I can write Spanish. In fact, writing Spanish is painful, but reading it, I can pretty much get by. So lots of resources on her site. Next one, written by somebody called A&M Baslar, and they wrote about how you can improve your code reading skills. So they've really come with some helpful strategies for diving into that scary looking code base. And they make, again, a very good, but an observation that I think passes us by sometimes is that to be able to write good code, you have to read a lot of good code. And this way you can learn how developers think and how they can solve a particular problem. Okay, next skill. I know you're all going to cringe slightly at this one. So when I ran away from Java, I believe it was version 1.2. And in a few months, it's going to be version 17. Quite scary. But it's more than that. It's more than these 6 monthly releases that we get now. It's not just about knowing that Java 17 is coming. It's about actively having the required conversations about it. It's not just going to be your job to potentially upgrade the code to Java 11 or Java 17. It's going to be your job to write the business case, argue why the business should upgrade, performance and security. Yeah, but what does that mean? It's going to be your job to understand all the new features. It goes way beyond just writing code. It's all the other stuff that is wrapped around that. And we're never really taught to ask why either. We're never really taught to ask why we're actually doing that, why we are upgrading to Java 17. Should we even do that? I know most of us are probably still on Java 8 for various reasons, and that pressure is going to increase quite a lot in the next 12 months, I would say. Lots of resources here. First one from Dalia Aboshisha. She's written tools that can help you to upgrade. She's got a lot of information on her website. There's a blog and a video that you can take a look at for Java 8 and beyond. I dare say she might upgrade it or update it for Java 17. There's also Angie Jones. So Angie tends to focus on the testing side of things, but it's not just testing. I've done some of her courses and they're incredibly useful for every Java developer going. She's covered it from Java 8 and beyond, introduces all the new features from 9 to 14 and gives examples of using them as well. I dare say, I hope that she will be upgrading that to Java 17 as well when it comes. Right, next skill. I'm going to have a sip of this scarce water. Doing technical interviews. So even if you've got lucky to date and you haven't had to do one of these, well done. You will have to at some point, and you have to know, if you don't already know, that the whole system is completely broken. And it is a nuance of the developers that the majority of technical interviews we're asked to do will be asked to implement something that is not going to be run of the mill for our day job. It's very frustrating, but help is at hand. I'm picking on Trisha G again for this one because she has made some very interesting observations of, do we know how to remain a programmer? And do we know how to avoid being promoted into positions away from the technology and code that we all love? What about social skills? They don't teach them at uni either. What about the skills that you need that aren't technical? And lots more, so there's a lot of information there. Another person in the community who's very hot on this subject is Emma Bostian. So she has written a book called Decoding the Technical Interview Process. Now, these are all resources aimed at A, acknowledging the system is broken, but E, accepting that the system is broken and giving you some resources to help you ace it and help you get through that technical interview when you're asked to do so. Again, Angie Jones has covered this for don't play that video, thank you. Angie Jones has covered this for automation engineers, and again, video and blog as well. If you are not sure why the technical interview process is broken, you need to read this blog from Sarah Kasabian. So Sarah blogged about how they actually changed this process at GitLab, and they recognized that the technical interview process wasn't working for them. It wasn't working for their candidates. They weren't getting the candidates they wanted, and the candidates who wanted to work there weren't getting the jobs. So they changed it, and there's some very interesting metrics on this blog about how you can modify your technical interview process and what it actually did for GitLab. So if you don't know the problem, check that out. I put this slide in this morning because I saw this on Twitter and it made me laugh a little too much. If satire is your thing, you need to read this. It's a day in the life of a professional software engineer with as much sarcasm as I think any one of us can muster. And it effectively references the fact that technical interviews will ask us to re-implement all these different sorts of algorithms. And then you go into the real world and that's not what we do in our day-to-day job. So if you like dark, check that one out. Okay, next skill. You have to choose your tools. And yes, I know there's more IDEs, but there's not in the meme. At some point in your career, you're going to be asked to make decisions. You're going to be asked to potentially make decisions on which IDE you want to use, which library you want to use, which framework you should use. And you're going to need to be equipped and comfortable and confident to make those decisions. Now, like I've already said, net new code is pretty rare, as it turns out. We don't write the net new code. We just write this sticky tape and prayers and hope that it works. And that's far more realistic for the modern world. We also rely extensively on third-party libraries and frameworks, but they need management. And I have seen entire Scrum teams stop for multiple sprints because something needs upgrading or something hasn't been considered for a while. There's potentially critical vulnerabilities and it's a full-on down tools job. So managing your dependencies is crucial as well. There's a really interesting blog on this one from Kyla Matthews about choosing the right Java library. And I read this list and I thought, well, that's actually really obvious, but it's only obvious when you read the list. In that, do you like the API? It's going to be you that's working with it after all. What are your needs? Do you actually know what your needs are? How popular is it? I don't think people pay for ratings in this sphere. It's not Amazon, but what's the testing status? And ultimately, you will learn more by doing. It's about getting familiar with Maven and Gradle as well for managing your dependencies, knowing your upgrade strategy, like I said. And I haven't got a resource here for picking an IDE because there's lots out there and you will know which IDEs you prefer and you want to use, but find one that works for you. That is the most important thing. Okay, next one, being a team player. So the bad news here is that your team are quite like your family. You don't get to choose them. You're also not the lone wolf that you potentially were when you were at university or boot camp, although there's more pairing that goes on at boot camp. The problem is many of us have absolutely no clue how to do this. And I was one of them. Throughout especially my early career as a technical writer, it became very obvious to me very quickly that the last person a developer wanted to see 2 days before the release was the technical writer. They made that very clear. But then I went on a mission of really getting to know the teams because I'd be working across lots of Scrum teams right across development. And I was usually the only person doing this. Everybody was in their teams, but I had to pull it all together to present the product. And I got to know the people and I got to know what their hobbies were, what their partners were, their kids' names, their fur kids, What drove them? What stressed them? And how did they like to be approached? Did they like an email, or did they like a coffee and a slice of cake? Like, what worked for them? And then all of a sudden, 2 days before the release, they don't mind having a chat with you. So you have to factor your teammates in and work alongside them, even if you don't get to choose them. And it takes a lot of effort to do this. And we all know that to go somewhere quickly, you go it alone. And to go somewhere far, you go as a team. So resource-wise on this one, very interesting blog from Offer Vogman. So they talk about the technical skills, they're only had the story and how teamwork matters. The strength of the teams in each individual member, and the strength of each member is the team. So he goes on to give some tools for kind of managing this, like leaving your ego at the threshold, embracing feedback, not always easy, being accountable. And the last one I really like, don't be a knowledge hoarder, because what happens when you're a knowledge hoarder is that people come and pester you more because they can't get the knowledge anywhere else. Another really interesting blog on being a team player from Alison Danisco. She comes up with 10 ways to be a better developer. And she talks about things like psychological safety, encouraging participation, assigning credit, amplifying unheard voices. You know, that person that sits in the room that never says anything. Giving constructive and actionable feedback, accountability, educating yourself about diversity and inclusion and equality in the workplace. Okay, next skill, solving problems. There's a certain mindset that goes a long way when you're a developer, and it's one that doesn't come naturally. It's one actually I still really struggle with. There's two strands to it. The first one is keeping it simple, right? You want to impress, you want to show everyone what you can do, you want to please the boss, but all this stuff comes at a great professional and personal cost more often than not. It's about being able to keep your solution as simple and as stupid for as long as possible, and then building on that complexity. The second strand is, as per the cartoon, it doesn't work. Why doesn't it work? Versus, yeah, it works. Bit weirded out by that. Don't really know why it works. And then there's the quote from Steve Jobs in that everyone in the country should learn to program a computer because it teaches you to think. And I think a lot about that quote because whilst it sounds a little bit cliche, I think there is value in that because it's about being able to mirror your thought process and problem solve. So I went digging on this one and I found this interesting article from Richard Rees, and he comes up with, well, firstly, he talks about the framework, or the approach, I should say, that most of us use when we're trying to solve a problem. First thing we do, we try a solution. Second thing we do, if it doesn't work, we try another one. Third thing we do, we go back and repeat step 2. And we do this, like, you know, hitting our head against this wall until we luck out. And sometimes we might luck out, but it is the worst way to solve a problem. And it is a huge waste of time. So what Richard Rees proposes is we use a framework and we break things down. So the first thing we do is we try and understand the problem. What exactly is being asked? Are we clear on that? Second thing we do is we plan. We don't just dive straight in, we plan. Third thing we do, we divide the problem space. We chunk it down into little bite-sized nibbles. Fourth thing, we get stuck. Now, we might luck out at this point, but let's assume we get stuck. So he then goes on to talk about what we can do when we're stuck. So we can debug, we can reassess, we can research. But breaking things down and using a framework is going to get you the results and solve problems faster rather than try this, doesn't work, try this, doesn't work, try this, doesn't work, try this, doesn't work, until 5 o'clock comes and I would say you go home, but you leave the room. Okay, next one. I promise this is the only annoying GIF in the whole presentation. I'm going to stop it in a minute. At Gravity Falls, if you haven't seen it. So cell phone. In fact, you know what? I'm going to stop that GIF right now. Yes. I didn't write a single test at university. Not one. And then I went into my first job and I had to write tests and I was like, yeah, I got no idea. Now, regardless of what you think of test-driven development or whether you practice it, it's a concept. It wasn't really around in the 90s. I think Kent Beck pushed it back into the spotlight in the early 2000s. It's very popular. I don't think it's a cult. But we are rarely taught to write tests. We are more in the bootcamp and practical side, but not really the academic side. And we are more often than not taught to write the code, bow, pedestal, and then think about writing tests for it. And there's been an explosion of popularity of Java testing frameworks nowadays, JUnit, Mockito, Spock. It's understanding the value of writing tests, and that writing code includes writing the test, irrespective of TDD. It's about having the confidence in the code, and understanding that testing goes a long way to achieving that. So, Kent Beck's book, if you want it, purchase it from, a nice independent bookstore, not to make someone else super rich. That's interesting. My slide is going backwards. There we go. Right. Blog from Dave Cheney. Now, he came up with this amazing quote, which for me sums it up. If you don't, someone will test your software. And if you worry about who will maintain your code after you're gone, write good tests. He talks about who should perform that testing, proportion of manual testing, if any, what those tests mean for your main branch, and how they can give you confidence to change your code. Okay, next skill, working with VCS. I've put Git in brackets there because I think most of us are going to be using Git professionally, personally, or both. So another cell phone, they're coming thick and fast at the moment. So my version of source control was zipping up my code base and dropping it on the desktop. I reckon you've all done it. However, we frequently and quickly, as we progress through our careers, have to become proficient with the version control system. We have to, it's a complete given. And you will do so very quickly. You will be able to clone the repository, make a branch, do a commit, basic merge, push, all that jazz. You'll be able to do that. But there will be a day where you will forget to create the branch, and you will put some changes on main, and you'll check them in. And then you'll do the same, and then you'll try and shelve those changes, and then the IDE will give you an error, and then something else will go wrong. And before you know it, there's some error messages about upstream and detached head, and you want to cry. And more often than not, you message the resident Git expert in the team. Now, every team has one of these, and in my old team, it was a guy called Paul. Now, Paul, in the end, did a very well-attended engineering lunch and learn on all the different ways that Helen had screwed up Git. And that told me two things. It told me, firstly, from the fact it was well-attended, very few people had his depth of expertise in Git and wanted it. And it taught me that I'm very talented at screwing up Git. But there is huge gains to be made by being familiar, not just with the Git model, but how to get yourself out of trouble. How to wind yourself back, wind the code back without having to phone Paul, because it would be much more valuable if you can get yourself out of trouble when it comes to version control. Good news, wealth of resources in this department. This book is one you need if you don't already have it. It's from Katie Cylon Miller, and it's called Oh Shit Git, or Dang It Git. It goes from the problem point, like, I accidentally committed to the wrong branch, me every day, or I need to undo a commit from 5 commits ago, me every other week. So what did you do? And then how you can actually roll that back. So it's excellent. I recommend you check that out. There's also a website which Tom Cools pointed me at when he saw this presentation. In that, and I can't believe I forgot about it because I've used it myself, but Learn Git Branching. So this is maintained by somebody called Peter Cottle, and it is a brilliant visual representation of what's going on with Git when you're actually doing your check-ins. So if you're not a Git expert yet, go and check this out because you will definitely learn something. If you're completely new in your career, then this blog is the one for you, because I've still seen very experienced developers, including myself, get very confused between Git and GitHub. So Aisha Ruat has written a blog on what is Git and GitHub and Git versus GitHub, because the terms get incorrectly used interchangeably. Okay, next skill. Reviewing code. 10 lines of code, 10 issues. We've all been there. We've all been party, or if you haven't yet, lucky you, been party to a toxic code review process. Some of us may even have participated unwittingly in them, and we probably don't feel great about that. Again, we are taught to write code, and then we submit it and it gets marked. We never go through, oh, could you review Joe's code and check out what she's done? And that just doesn't happen. And then all of a sudden we're out in the real wide world and somebody says, oh, can you review this code? And you sit there going, yeah, sure. What am I looking for? We can all say the method name doesn't follow convention, or why have you used that loop construct, or etc. But it's about knowing what you're giving feedback on and why you're giving it, and also recognizing that there is a person on the other end of that feedback. Resource-wise, Angie Jones has taken a very human approach to this. She talks about how not to take it personally, how to detach yourself from your code. I know you wrote it, but it's still code. How you can look at all the feedback, how you can contribute your rationale. Why did you code it that specific way? Don't be afraid of saying that. How you can compromise, and of course, treating others how you'd like to be treated yourself. Sticking with reviewing code, Dr. Michaela Greeler has written some very interesting material on this. I've seen this so many times. Some team fears and some teams experience the main drawback of code reviews is reduced coding velocity. So their productivity is reduced because code reviews slow the team down. And then if that's not bad enough, if that's paired with a meaningless code review, then it's a nightmare for everyone involved. So Dr. Michaela Greeler has looked at this and looked at ways that we can actually address where we've potentially got code reviews in a team that are not helpful, slowing the team down and not giving value for time. Okay, debugging. Oh no, it's another cell phone. So debugging your system. I used to debug with sysout statements. Are we in this loop? Are we really? It's not very efficient and it's certainly not very fast. IDs weren't really around when I learned to code, and 20 years later, I'm blown away really by what the IDE can do for me. They do have built-in debuggers. They are incredibly valuable. I strongly suggest you learn how to use your debugger before you need it. Because when you've got a nasty bug, you don't want to be learning how to use your debugger and applying your brain power to debugging your bug. I initially struggled for resources for this one, which was both a surprise and then not a surprise. And then I realized that I follow somebody on Twitter called Julia Evans. I am a huge fan of her work. And she very recently put this tweet out there of, when you run into a bug, like, what do you think is blocking you from understanding it? And she, I believe, is going to create a Zine out of the answers to this. So she came up with this list of, it's hard to reproduce. Our mental model might be missing something. We might not have the tools we need to actually inspect the program state. One of our assumptions might be wrong, or the bug's just really blooming complicated. And it could be any one or any number of those things that really is contributing to the fact that we are struggling to debug that code. Okay. Estimating stories. Yeah, we've all been there too. Oh, it's a 3. Oh, it's actually a 20. Again, this is a complete contrast from when we're learning. We are given an assignment and we are told it is due in 3 weeks. And we sit there and we think, okay, 2.5 weeks in the pub, half a week to do the assignment. That's how it works. And then we go into the job and somebody says, so how long is this going to take? And you have no idea. And there's all these eyes looking at you and you have this strange deck of cards. And we are always under pressure to commit, to deliver. And again, like I've already said, that can come at a really personal cost. So what do? How do we get better at estimating? We look at history. history is a great teacher here. We use our judgment and we learn from our mistakes. We also know when it's being used as a stick. And what I mean by that is if you've got somebody in the room who's not part of the Scrum team, who is trying to force the estimate down or even up, that should be ringing alarm bells for you. If you're not clear what the problem is with estimating stories and why it's so hard, then imagine this scenario. You're going to go camping. It's going to be 6 to 10 people. Some haven't confirmed yet. The trip's going to last 3 to 5 days. Everybody has different food preferences. Buy some drinks, not too many. Don't forget the tea. That's why I like this example, being British. Get the best possible quality. And before you even go into the store, tell me how much it's all going to cost. That's what estimating a story is like. You're working on a bunch of unknowns and you're working on a bunch of assumptions. So you have to break down the work. So this is what Boston talks about. This is his example. This is what he talks about, is breaking down the work, asking questions. Don't work on assumptions. Adjust the requirement if you need to. Take your degree of confidence into account. Use a sequence. I think most agile teams do that already in terms of Fibonacci sequence or whatever it is. Set a maximum number of hours per week. And don't forget the things we tend to forget about. And for me, that's about context switching. It's about getting in the zone because everybody always forgets that. And the number of meetings you have a week as well, which I'm going to come on to. Another interesting blog by Maddie Osman, Why Software Developers Suck at Estimating. So she comes up with 4 main reasons. Parkinson's law. So it will take however long you give it. You give it a day, it will take a day. Everyone's different. Of course, we're all different. We always forget that, especially when we're part of a team. Software development is a process. It's not just writing the code. It's all the other gubbins you've got going on around it. And it takes time to get into the zone. You can't just turn up and work on, at least I can't, 4 different things in the zone of one day and not have a mental cost of context switching. Okay, next skill. So here we are. We're taught to write the code, got the bow, got the pedestal. No one ever tells you to delete it. We're never taught that code has a life cycle, and we are certainly never taught to delete code. Again, it's another place where IDE can help you with highlighting unused code and deleting it safely. But we're never really taught that code shouldn't live forever and that code does have a cost to it. So there's a couple of resources here. The first one is, I was told to take this slide out, but I didn't. This is a blog from Melissa McEwen, and she talks about how she will delete commented out code without reading it. And she's not sorry. And that's clearly an inflammatory statement, but it's a very interesting statement because what she was saying is if there's commented out code, that's what version control is for. So why is the code commented out? Now, she does then, once she's got your attention, take a step back and say, well, there are various ways to approach this. You can catch it before it becomes like this comment junk. You can uncomment it and see what it does. You can turn it off. It's controversial, but it could be worth tracking. There's also this amazing story which was published in InfoQ a little while ago. Short version, manually patched the New York Stock Exchange system. Because they did it manually, they didn't know one of their deployments had failed. It left an old version running. They had also recycled an old flag, the flag that should have been deleted. And it was now repurposed to mean something completely different. And when the system went live, the old code awoke and zombie apocalypse arrived, and it resulted in a loss of 10 million per minute off the New York Stock Exchange. So if you like, grim stories, that's a good read of why we should maintain and delete and give our code a life cycle. Okay, pair programming and mob programming. I've recently started doing this. Again, it wasn't something that we really did. It is incredibly rewarding. It is also mentally exhausting. It is about turning up, bringing your A game. One of my favorite things about pair programming is if you're both using the same IDE, you get to see all their IDE tips and tricks. So that's an added bonus. If you want to learn your IDE, just pair with somebody who uses the same IDE as you. There's quite a lot of opinion pieces around pair and mob programming. So the first one is Helen going backwards with her slides. The first one is from Sam Fair, and he did mob programming every day for 5 months. And he makes a very interesting point in that, why do we call it mob programming? Like, mobs are the opposite of what you really want from a successful programming session. They're disorganized, they're prone to rash decisions, they're angry and unwilling to compromise. But fortunately, mob programming is none of these things. So he talks about his experience and what he learned from it. Contrasting to that, there's a very interesting blog by somebody called Nat Bennett. Now, Nat was part of an experiment for 6 years where he paired all day, most days for years. Hundreds of other engineers did it as well. They're working as a software engineer for Pivotal in Cloud Foundry Research and Development, and they paired for 8 hours a day. And the quote there is something that's kind of stuck with me, in that he says, it's one of the best things I've ever done for myself, socially and emotionally. And it produced some great software. It also burned me out. So that blog is a very interesting read. It looks at it from both sides, and the mental cost of having that kind of intense experience with your colleagues every day for 8 hours a day. If you've not done pair or mob programming before and you have no idea what I'm talking about, Martin Fowler's blog had a couple of guest editors, Brigitta Bockler and Nina Sesega. They talk about, from the beginning, what is pair programming? Who's the driver? Who's the navigator? Red, green, refactor. What are the benefits? What are the challenges? So if you've not done it before and you want to try it and you want to introduce it perhaps to your place of work, check that one out. Okay, next skill, managing meeting load. I need a poll here of who here likes meetings, but I'm thinking it's going to be not many hands. So I once worked with a guy who was so proud of the number of meetings that he had in one day that he posted this on a popular social media platform, and he associated that statement with how busy he was. And I just didn't know what to make. I didn't know what to do with myself. I was like, that's not productive. That's just not productive. And it got me thinking why I'd had such an extreme reaction. And I think it was because writing code is productive. That's what we're taught. That's our job. And if we're in meetings, we are not doing that. And it really drove home to me just how little coding work we get done some weeks. Meetings also have a really heavy context switching cost. Again, it's the opposite to what we're taught. It's we don't have to go to meetings at university. We just have to deliver beautiful code. That's the story. There are some things that we can do to help ourselves. The Eisenhower matrix, you'll all have heard of it, but you probably don't regularly use it to prioritize your work. And I encourage that you do. If it's urgent and it's important, do it. If it's urgent and it's not important, give it to someone else. If it's not urgent, but it is important, plan it in. And if it's not urgent or important, what the hell is it even doing on your to-do list? Just get rid of it. It's very useful to go through that process every now and again, just to make sure that the work that you're doing is correctly prioritized and it's the right work as well. Another interesting blog from Dan Lyons, he talks about why we have too many meetings, how we hate meetings, and he gives us some tips to help as well. So take a meeting inventory, all your sprint meetings, what does that actually add up to? Add in the ad hoc meetings, all the time the product owner says, can we talk about that? What's the value of each meeting? Position them correctly, group meetings if you want to, improve the transparency of that whole process. Okay, switching contexts. This can be planned. So sprint, you will have probably multiple things you need to work on in the sprint, and it can be unplanned. So those are your life curveballs and your drop balls, and you'll pick them up and life will throw you more. That's just the way it goes. But there is a cost to switching contexts. And I didn't actually know that this had a name, but this blog from Mayumi Nishimoto talks about the cost of switching context on developer productivity. And the name is attention residue. And that's where our brains cannot switch off from one task and straight to another. I used to think I was amazing at this. Turns out I'm really terrible at it. If you have a meeting at 9, at 10, 11 and 12, your poor brain come 1 o'clock is probably still thinking about the meeting at 9 a.m. It's completely at odds with the way our brains are designed to work. Like, we can't do it. Stop kidding ourselves. So have a read of that, because understanding what attention residue is and how we can schedule time for regular deep work and time box and use anti-distraction apps. And I assume practice digital minimalism is putting our phones away, but whatever that looks like, we can practice it. Okay, I can't do a presentation like Grumpy Cat. It's just not in my makeup. We get it. You don't want to annoy the boss. You don't want to let the team down. You do want to progress your career, especially at the early stages. But sometimes, actually most of the time, you have to say no. And you have to say no because burnout is real. And the toll on your mental health is real. You have to set boundaries. You have to set the priorities. So Hussein Pollitt-Urich has written about this, and it is the most important skill a programmer can learn. Every line of code you write has to be read and understood, tested and debugged. It'll probably increase the defects, and it will probably introduce new bugs. So do you need to write it? Should you say no to that? If you're not sure how to say no in the right way, Daniela Petrova has written about this on developer workload. And she talks about why you need to start saying no, when you should start saying no, and how you should start saying no. So respectfully, honestly, and offering up an alternative. Okay, penultimate skill. You have to be aware of your mental health. It is no secret how fast moving this industry is. Like, I took 20 years out from Java. I'm catching up. It can take a hugely detrimental toll on your mental health if you're not careful. We have to factor in the importance of mindfulness, of rest, and having those around you as well. Your support network, it might be in tatters by the side of the road right now, but find it, rebuild it, because you're going to need it. Take the time off, recognize when you're on that path to burnout. Many of us on this call have probably learned that the hard way. Don't do it. And also, I do want to point out, especially to those of you who are newer into your career, you do not need a side project. You do not need to hustle to be a great developer. You don't need to code on your weekends. So, great blog here from Lena Kozar and Vova Vok. They talk about how mental health in software teams manifests and interacts. They talk about focused and unfocused modes, and don't forget to work out. They talk about the importance of teamwork, especially now when we're mostly at home and split from our teams. Turns out oxytocin isn't just useful in childbirth. It's getting some happy, it's getting some hormonal highs and enjoying what we do. There are a couple of great blogs as well by Brian Robinson that were published in Forbes, and these have some really interesting statistics in. 48% of us have experienced burnout. 61% of us elevated stress. 32% of us have felt lonely. The second blog I would encourage anybody to read, especially if you're currently remote and you're being asked to go back to the office, because it is some red flags to look out for that a psychological safety is not being prioritized with a remote workforce. So it's things like there's no senior leaders who work remotely. Digital communication tools have not been prioritized. Team or company-wide meetings are scheduled at odd hours. So if you're in that situation, check out that second blog. All right, last skill, got to end on a happy. Have a great work-life balance. It is so important, and it's so hard when we're all working from home. Many of us have kids at home. We have potentially family at home. We have God knows how many stressors with everything that's going on at the moment. So work-life balance is absolutely critical. Really great blog here from Anu Padye. They talk about prioritizing your time, following a strict routine, cutting out the things that aren't important. Like I said, burnout. Don't be a perfectionism. It is the enemy of getting shit done. Learn to say no and enjoy yourself. Next one from Karina. So in this blog, she talks about balancing work life as a developer, and she talks about how you can prioritize. You can't know it all. Improving your efficiency and creating the time. We're all very good at saying, oh, we don't have time to do that, but it's about carving out that time and creating that time as much as it is anything. At the end of her blog, there is a TED video from Nigel Marsh, and it's not a long video, and it really drives home you don't need to make big changes to have a better work-life balance. I don't want to ruin it for you. So go watch the video, because it is a very touching moment towards the end of the video where he realizes what the idea is that's worth talking about and why he turned it into a TED Talk. So to summarize, writing code is what we're taught and what we learn. But being a great developer is all the other stuff. It's about all the stuff that we learn on the job. And it is hard, and they are skills in their own right. So what do you do now? Well, this is your call to action slide. Apparently presentations need one. There is going to be a QR code on the next page. It's going to have all the resources and further reading that I've talked about. Pick and choose, bookmark it for later. This is also the part where you give yourself a huge pat on the back. Just generally, you're rather awesome at this stuff, and I hope you realize just how far you've come. This is also the part where you go and help someone else who is new to the industry. They not only won't have these skills, they might not even know that they're going to need these skills. So this is the part where you show them the way. That's the QR code where you can get all the resources. I'll also put a link into the chat for it in a minute. Thank you for your time today. 1:53, perfect. I really appreciate it. And I hope you've learned something for yourself and your career, and you can help lift others up who are just starting their career. Thank you very much. Finished.
Thanks, Helen.
Let me get a link to, thank you. I'm just going to grab the page and put it in the chat for you as well, which I should have to hand, but I don't. Cool. Does anyone have any questions or comments or feedback? Good, bad, ugly? Well, not ugly. Don't want that. Oh, there is a question in the chat. Ah, it's scrolling. What do you think of going back to the academia for a master's degree or something similar after? Ooh, good question. I would say, if it feels right for you and you have the financial stability to do so, I guess if you're asking a question like that, you have a goal in mind, Alan, in terms of what you want to do and where that qualification is going to take you. If it's what you want to do and you have the means, I would say absolutely go for it. It might be a very interesting experience, especially with all the practical skills that you'll have from your career to date. So yeah, I would go for it.
I was going to ask a question, like I suppose what skill set do you think is hardest to learn out of all the ones you mentioned?
Which one's the hardest?
Yeah.
For me personally, I would say test-driven development, because it's just not something, I mean, we didn't really do tests, let alone test-driven development. So that's definitely been the most challenging one for me, I would say. Hang on, there's another question. Do we really need a mentor during our work? Do you need a mentor? No, I wouldn't say so. Mentor is one of those funny words. Depends what it means. If you find a mentor useful and you want to work with them on certain things, then definitely. I have mentors for a number of things, including public speaking, and I find it personally very useful. But do what works for you would really be my best advice there.
Are there any other questions at all from the audience? Feel free to unmute.
Right, let me just drop the link to all the resources in the chat as well. There?
Another question that's come in. Ooh. What are your tips? Oh, sorry.
It's all right. Even if you're a great developer, yeah, true, you can. What are my tips? I would say evidence your work is probably the most important one, especially if you feel like you're being shadowed. Potentially, I think that means overlooked. So every sprint or every month, write down everything that you've done and everything that you've contributed to, because you can't really start any form of conversation unless you can evidence what you've been working on and what you've delivered and participated in. Also have a think about what areas you need to grow in and what areas you want to grow in, and could they put training plans in place to support you in that. I would say that's going to be your most important thing to do, especially if you're worried that you are being shadowed in that respect. Thanks, Chris. All right. Well, if anybody wants to get in touch or say hi, I'm on Twitter, Helen Jo Scott. DMs are open, so give me a shout. And yeah, thank you all so much for giving me your time today. And thank you, Sam, for hosting. I'm going to shut up.
You're most welcome. Thank you. Yeah, thanks everybody. So this recording should be available within the next couple of weeks, week or two. So yeah, thank you very much for attending, and see you soon.
Thanks,
Bye.
Thank you so much.